Alrighty. Okay. Good morning, good evening, good afternoon, everyone. So today will be the fourth lecture with our network and Dune, and I'll be covering DEX data mostly. I don't think actually we're gonna have time to cover DAO, but if time permits, I can just quickly go through whatever the content I prepared. And I believe we're planning to have another focus group for DAO topic potentially. It's so hot right now. And introduction of myself a little bit. I'm data scientist with Xerox right now. Xerox is used to be known as a DEX, but right now it's more like an aggregator by definition. Before Xerox, I was at Consensus for around 3 years. Back then, I was like looking in more like industry level kind of data, but then now I'm like just looking into DEX data every day. Also, me and other like data people from different DEX team, we've been building this dex.trades table with Dune since the beginning. So it's kind of how to say a lot of things going on there. There can be also a lot of information to decompose today. So this is kind of like an ambitious agenda, but let me quickly go through it. So we want to talk about like DEX and DEX aggregators. What is the DEX? Just to make sure everyone is on the same page, regardless how much DeFi knowledge you have. And then we think from like a data person standpoint, right? How should a trade table look like? What kind of fields we should include in this trade table? And then we will try to decode from the low level events or contract call, whichever we found would be the best one to trying to construct a table for including all the Uniswap v3 swaps. And then like if we are able to build this whole table, on top of it, we can query, for example, what's the volume over time for Uniswap v3? There will be a lot of joins there. So today, basically, we can progress a little bit in more complex join. And then I want to go through like this famous DEX metrics dashboards with y'all, just to have a sense of like as a data person, as a data analyst, what kind of metrics we usually look at for the DEX topic, the vertical. And then we can take a look at this actual dex.trades table. And then how to say just cover a few concepts there, and then we can try with a window function to come up with a solution with this question about what's the top 10 traded pairs per month on DEX over time. Yeah, and then for DAO, I was gonna trying to walk through a example for compound governance, where I believe there are like one of the earliest DAO or governance where basically people can create proposals on their forum, and then people can vote with their voting power. And with the data, everything is on chain. We are able to actually decode all of them and see, okay, so for each proposal, how was the voting look like for each of them? Like how many people voted yes, how many of them voted no? Yeah, but how to say, a friendly reminder, if you're just here for the DAO, probably we won't go that far. So you can drop, I guess, already. And we can cover it in another focus group. So mostly it's going to be DEX. And I actually also checked some other sessions from other lectures. I believe they've been how to say covering a lot of like concepts in terms of SQL. But like today for me, I would like try to really all right, let me quit Slack. I would really trying to cover more concepts about DEX or like DeFi. And I want to do it in the way of like more like using instinct. Does that sound all right?
Yeah,
Yeah.
I can hear you.
Okay. Okay.
Yeah.
Yeah. I want to be more like from my instinct. What am I gonna do with these questions? From which point we should find the information. So here we go. What's DEX? So decentralized exchange. I believe most people are familiar with it. If you're talking about a centralized exchange, it's Coinbase. Everyone trying to use it to fiat on ramp from US dollar or any other dollar to actually enter the gate to get crypto. And then once you get a crypto, you are basically in the DeFi world, and then you can trade any token from any token in DEX or aggregator. So this is like a brief history of how it evolved from like 2017, how it started. Initially, I think the earliest one was like IDEX, Ether Delta, and then also like 0x3 layers. So initially, I believe order book DEX was pretty popular. Basically, we have this concept of like two people, Alice and Bob. One is a maker, one is a taker. I think maker can be usually defined as the person who raise an order first, saying, "Oh, I want to buy, let's say I want to buy USDC and sell WTH. Who can take my order?" And then the person who see this order from the order pool gonna say, "Oh, I want to trade that," and then this person becomes a taker, and they're gonna sign the orders. And that's like the naive model of order book DEX. And then later on, 2018-ish, Uniswap came out, and then they introduced this idea, this great idea that what if we can use it as like AMM model, like automatic market makers. So basically saying, you don't need to find the exact perfect match for your order to actually, match with your orders. But like everyone can deposit their liquidity into a pool saying this is a pair of WTH and USDC, and we're gonna have a like math formula like XY equals to K kind of thing to define the pricing for this pair based on like the current liquidity distribution in the pool. And then whoever comes here, they can just say, "Oh, let me check the price for this amount of token I want to buy." And then if they agree on the token, and then they're gonna just take the order from the pool. So like in this scenario, we have more than just the trader as a user. For Uniswap, you can also be a liquidity provider, which is like LP. There are a lot more metrics that are interesting. People are discussing about like impermanent loss and TVL, capital efficiency. But I think that's going to be like advanced class later in the future. And so in this case, when we're talking about the trading part, the person who comes to the pool always is the taker because the liquidity is there already. And so like in data format, right, what we're going to see as a maker is going to be the pool contract address. Yeah, so that's AMM DEX. And they prove to be like really efficient in terms of like pricing and also like liquidity, availability. And then so as it goes, 0x and actually also 1inch and Paraswap come up with this idea of like, okay, so that looks good. And what if we combine both of the models and maybe even trying to introduce more liquidity, which is what we label here as RFQ. Request for quote, which is working with mostly the professional market makers who have like big funds sitting there that they can provide a quote for the traders, whoever want. So this is like aggregation, aggregating all the liquidity together and then come up with like the best price for the taker. So let's say, if you look at this diagram, like for example, for Matcha, if you come to matcha.xyz, and basically you are as this person, as a taker saying, "Oh, I want to buy WTH and sell USDC." And then Matcha gonna send this request back to 0x API. And then 0x API gonna compare Uniswap, Sushi, Curve, Balancer, all the other liquidity, and then also check the order book we maintain, and then also check with our market maker saying, for this trade order, how much price you can provide, and then come up with comparison, and then like give the best one back to Matcha's front end saying, we get you the best price from maybe Uniswap actually. And then if the user agrees, and then they're gonna sign up the order and then sign it in MetaMask, and then that's gonna be how a trade look like for aggregator. And then now it's like next level with CowSwap. It's like they're like the aggregator of aggregator. I think one key design for them is like they want to batch users' trades together. So basically saying three, for example, like 5 orders or 6 orders gonna be all executed in one batch, which means no one can, jump the line and insert it between them. So like sandwich them or like front end or front run or back run end, which is a pretty novel solution they designed for avoiding MEV. But also, I would say like with their design, they're comparing also not only AMM, but also the output from 0x API, which means they are sitting on top of aggregator as another aggregator. So that's why like I'm saying like this is aggregator aggregator. Yeah, so it's getting pretty crazy. So how should a trade table look like? So when we think about if we are looking at like the DEX trading volume, or if we want to say we want to cover in the media saying how is the DEX vertical or like the DeFi ecosystem going on? What are the elements we need from this table to actually report those information? I guess, okay, I'll just go through here. We for sure need to know the information of the two sides of the person who are participating in one trade, which we can call them maker and taker, but their definition can be less strict nowadays with more complex model. So like with the dex.trades table, we just call them trader A and trader B. And then so basically that represent Alice and Bob, or maybe the AMM pool contract and then the taker. And then we need to record the information of what token they actually swapped. So we want to know like maker token and then taker token, or call them like token A, token B. And then for token part, the information, how to say, there are different information associated with the token. I believe other teachers also covered this in the previous sessions. Like each token has a token address, which is a unique ID for them. And then they're gonna have a symbol, but it's possible that sometimes the symbol, without differentiating, how to say, lowercase and uppercase, there can be same. So it's not reliable to join when we are joining, we use the symbol. So still, the lowercase of token address will be a better thing to join on. And then so we also actually need to know the token decimal. So to actually divide when we are decoding the raw amount from this swap. But I didn't put it here because in the final table we have for a trade, we probably don't need it. But definitely in between, we will need that information to calculate the amount. And then we want to know like how much token they swapped for each side. And then so basically it's the same maker token, taker token, and then also like potential this can expand to be like raw amount, which is as we know, like for example, 18 digits of ETH, WETH, it's gonna be like a astronomical kind of number. And then that will be the raw amount. And then if you divide it by the decimal, it's gonna be look like maybe 1 ETH or 0.01 ETH, something like that. Some special case that you're gonna how to say you're gonna keep in mind when you deal enough with this data is like USDC is 6 digits and WBTH is 8 digits. So it's not safe to assume that most of the majority tokens are 18 digits. We always want to look up the token table to make sure the decimal are correct. And then, so even if we know that, oh, this trade is traded in ETH of like 10 ETH, we still want to, how to say, quantify it in the USD volume. So we want to have like a volume in USD, or like call it USD amount. And this is actually a tricky part because we need to we need a conversion from each token into the USD dollar, and which means when we want to know what's the token price for this trade, we need to first join on the token address as a unique key into like a price table. And then also we need to know exactly that moment, which means there's going to be like a two key for this join. One is the token information, which is token address. Another is like the maybe specific timestamp, maybe minute level or hour level. So yeah, this to get this, we actually need to introduce like maybe two more tables in the join. And then of course, we want to know some blockchain level basic information about the transaction. We want to know when it happened, the transaction timestamp, which is going to be associated with the block timestamp. And then that will be like the finest granularity we can get. And then log index, which means So this is specifically saying if we're decoding this trade or swap information from the event logs, and then for each event log, they have like a log index that is unique towards inside of each transaction. So the log index will, how to say, let me give a concrete example. So as the contracts are growing pretty complex today, if we're swapping on Uniswap or any other maybe platform, it's possible that one transaction can have multiple swaps. So we want to record not only transaction hash, but also the log index for that specific event log. And they how to say, these two elements together can be a primary key here, as actually the question I put here. And it's also useful to log the contract address, basically, which means from which contract this event log was logged, or or sometimes in some DEX design, for example, like Uniswap, the contract that is logging the swap event is actually the pool contract. So if we get this information, we are able to either know which pair it is, or in other DEX design, we're able to know maybe which version of this is. Yeah, and then DEX name, as we can actually manually encode, and then protocol version, which is also we can manually encode. So yeah, so this is a screenshot of how actually the DEX trades is initiated in Dune's repo. Also, this repo is public, so I'll just take a tour quickly here. So in Dune Analytics repo called Abstraction, under Ethereum folder, you see there are so many actually DEX and Lightning Protocol as well. Has a folder under it, which is dealing with a lot of like token or like table decoding. This one looks like just a constant. Like for example, for 0x, we are maintaining a few materialized view to account like the total number of fields. Yeah, and then you can actually find this folder called DEX, which is where the dex.trades table live. In the trades folder, um, you can see for each protocol, we have a query file. For example, let's say, look at Uniswap. We had version 1, version 2, version 3. So whenever you are not sure how it was decoded from a low level, you can actually come here and see and check like how it was decoded. And then all together, they come up with this DEX trades. So let me go back here. So yeah, so we just discussed how a trade table should look like. I guess maybe I should pause. Any questions or any comments? Okay, cool. And so we were talking, yeah.
Oh, sorry, I was a little confused about how, so like how can we check, like what can we check on the GitHub repo for
Yeah,
the decode that you mentioned?
yeah. So this whole repo is like a public repo, and this DEX folder is basically how from how to say different module, or I say like for different DEX, how this whole dex.trades table are how to say constructed. So you see there are so many DEX here, like Dodo, Kyber, Loopring, Mixex, and then like each team actually come here and commit to the GitHub repo to to update however we need to decode the protocols. And so like you can actually check here from if it's from like events or from contract call, they are decoding one swap. Does that answer the question?
Yeah, yeah. Okay.
Okay, okay, cool.
Yeah, thank you.
Yeah, so of course. Yeah, so and then so as we just discussed here, this screenshot shows like how actually DEX trades table look like per each fields. We see blockchain block time, which is the blockchain block timestamp of the transaction, and then token A symbol, token A amount, project version category, trader A, trader B, token A amount raw, token B amount raw, USD amount converted, token A address, token B address, exchange contract address, transaction hash, transaction from, transaction to, trace address, event index, trade ID. So a few comments here actually. I wanted to zoom it out, zoom it in a little bit. Okay, it doesn't really work. But so one thing here is like, what is category? So category is a flag we're using right now with Dune to differentiate if it's a DEX or it's an aggregator. Why we need to do that? It's because like if we recap this chart, right? Like if an aggregator they're gonna log a swap event, it's possible that we are counting all the trades we send towards Uniswap as part of our volume as well. While actually on chain, it's also it's actually the Uniswap contracts logging the volume, logging the swap event, which means it's gonna be also counted when we just do the decoding generically with Uniswap, and then which means this is a double counting of the volume if we are just naively summing up all the volume. So whenever we are talking about or when we want to write a query saying, oh, I want to check what's the total volume of DEX market, make sure you check this category column and then make it equals to DEX. We can verify it here quickly with, for example, this is Sushi's query file, and they're gonna log themselves as a DEX in the category. Instead, if we go to, let's say 1H, they're gonna log themselves as like an aggregator. So which means they are sending volume towards other DEX AMM, and then the volume can be double counted. So yeah, that's just one comment here. And let's see. Transaction from is another interesting field we usually cover. The reason is because when we look at the trader A, trader B, it's whatever we can get from the event log. A lot of time, some some aggregator they may use one proxy contract and then send that towards the AMM DEX. And then very likely that address can be logged into the event as a trader A or trader B as a taker side. And then that's not the actual retail user who actually sent this transaction request. So in that case, if we're just summing up the number of trader A or number of trader B, we're largely undercounting the trading user or like the traders on a platform. So in that case, we need to track back the transaction from, which is the initial transaction sender, to make sure we're counting the user correctly. Yeah. And if we want to create another unique ID, we can also like generate a trade ID here as what Dune does here. So we were talking about one DEX, and then now if we're saying how we can create this dex.trades table, what are the how to say macro view of the structure look like? So as we went through the concepts of DEX and aggregator, I guess a few fields we may want to make sure that exist there. One is that we want to make sure we can differentiate from the projects. We need their name and potentially version as well. Like as we know, like Uniswap had V1, V2, V3, and like also we want to know if it's a DEX or an aggregator. And the reason is because we can potentially introduce double counting if we don't differentiate them. And so this would be a very, how to say, pseudo code way to present the dex.trades table. We gonna have, and I believe other teacher also covered this CTE thing. So we're gonna construct a union of all the different DEX trades with the same format as like a mega table. And then from there, we will need to join on the token information from the maker side as well as from the taker side. So like basically you see we're joining on one table, but for twice, because we need to get the information for each of the side of the token twice. And then also we need to join on the price table from maker side and also from taker side. And then as we mentioned earlier, this key here will be more than one. we need to join on the maker at token address and also like that timestamp of this trade to make sure we get that price specifically for this token at that moment. So this is just like the general idea, and then we're gonna actually try create this table. All right. Any question about the concepts? All right. I think there are some high level thing I summarized for myself is that whenever we deal with like new table, what I do is like first check how the table look like from the left side of Dune interface to understand, oh, okay, what are the things I can get from this table? Potentially, you can also do some select from limit 10 kind of thing. Just check if the numbers or how to say content look as you assumed. And then I'm thinking about, actually, I think about like the destination you want to reach. For example, like think about the final charts you want to produce, and then it's going to be pretty clear about, oh, what are the things you want to group by, and then basically you come up with a structure, and then everything going to be easier, I think. And then finally, even when the query runs, test it to make sure the results look good, and then look fucking good. So that's that. So I think now we're gonna dive into first exercise about creating a Uniswap v3 trades table. I will add a link of the query after the class before we upload the materials. So everyone, I guess you can try to start the Dune query console now. And I'm gonna also just go through my thinking process here. So like if I'm saying, oh, I want to create a Uniswap v3 trades, the first thing is that I want to see how the Uniswap trade look like in one transaction. There can be different way to find that out. I can make a trade on Uniswap and make sure I am like my trades go through the V3 pool, or I can I can cheat by just select one transaction hash from the DEX.trades, make sure it's from Uniswap. Actually, I actually found out one Uniswap contract here, and then we can look at it on Etherscan. And then if we click the events tab, so this is the Uniswap v3 USDC pool. If we look at the events tab, we see it's been firing all the swap events and mint event actually. Swap event. Actually, I'm curious, what is this one? Yeah, so it seems like someone deposited the liquidity in Uniswap. Oh, hold on. Is my screen showing the Etherscan page? Okay, cool. Actually, it is. Yeah, so I saw a mint event and I clicked into it and realized, oh, this is someone deposited liquidity into Uniswap. But let's go back and look at the swap event. So basically saying any of this transaction is one swap happen on Uniswap v3 pool. So we can try to look at it, the Dune table, to see how it looked like in the raw data. So I will grab this topic 0 because I would want to start from a low level to go through the Ethereum logs table. So let's say I grab this topic 0 as E420 something, and then always look at the table, Ethereum logs. So remember, for this table, the topic 0 is actually topic 1. So we can basically just check, let's say, select everything from Ethereum logs where topic 1 equals to this, and always just switch the 0x to like a -x, which is byte A, and then always limit it like, oh, maybe yes. Yeah, I'm the kind of person who doesn't actually capitalize stuff, but don't hate me. So it's basically how one Uniswap swap event look like in the Ethereum logs. Let's say we have contract address, we can check whatever it is in EtherScan. Let's say 0. Okay, so this is a Uniswap v3 fund. This is showing that this is a token contract, and it's also like Uniswap v3 pool. So okay, now I know each of the swap event is fired by a token contract. Empty data have a lot of FFFF. This is how to say, it's not common, but based on my experience as what I learned, this is showing basically it's a negative amount. So they padding F in the beginning rather than 0. And the way Uniswap is logging the information is that, like, because this is a pool concept, it's like they have 2 tokens. When you trade, one is coming in, one is going out, and they're gonna be just recording how much is added into the pool and how much is deducted from the pool. That's why there is like a negative and there's a positive. Actually, this is not very explicit, but we can look at it here. We saw actually it was topic 1 in Dune. So like this is showing index topic 1 is address sender. So topic 1 is address sender. We know basically saying, okay, so this is basically the trader who sent the transaction. They also log it as a recipient in topic 2 again. And then amount 0 and amount 1, which is in, let's see, you see this parameter list, we see index topic 1, index topic 2, and then the next one will be the first part in data. So basically saying amount 0 is here. And we see it's an int, and so we can convert it to number. And then this is amount 1, it's an int, so we can convert to number, but they have the padding in front as all the FFF, so which is messing up here. But actually, like if we remove the FFF here, like, and try to maybe decode it as a number, let's say hex to decimal. Just like a random tool. This number makes much more sense. So we will have to figure out how to handle this when we're decoding the data. And then next, what are the information? It's QRT price. It looks like some parameter in their formula in the pricing function. Liquidity, tick. These may be useful when we want to, construct the liquidity distribution for Uniswap pool, but not very useful at the moment if we're just want to get the token amount and then token information. So yeah, this is one-to-one map to what we are seeing here. Now let's try to find this information in other ways. Like we also learned that we can people can actually decode the ABI in Dune and then actually come up with a table. So actually Uniswap had this thing all decoded. We can start from there always as an easier way. So I believe this one is called pair event swap. Okay. Swap. Yes, so this is a table, also one-to-one map to the information we just saw. Let's give up this very primitive way, but query it from this table. So now take a look at here. Say we look at this table. Okay, everything is decoded, nice, and it's like also handled with a negative in front. So this is pretty nice. And let's just construct whatever the elements we wanted in the previous slide, right? So let's say what we want. We want everyone can do this at the same time, and then let me know any question or issue come up. I'm just talking to myself here aloud. Event block number is the basic information about timestamp we want, and as what we can see from this decoded table already, it's like a timestamp already. So actually a date timestamp already, and then we want maybe also block number. So it's called event block number. time. And then we want the trader A and trader B. So we know that this is a pool concept. So the maker side will be basically the pool contract. We can just put it as a null here as for now, or we can use the contract address. Call it trader A. Actually, I think usually we call trader A the taker. We define trader as a taker, so I'll just put this as trader B. And then trader A is what we saw earlier. Recipient is the transaction sender as the actual trader. So recipient is basically the trader A here. And then now we want let's say we want the trader A token address trader. Oh, let's call it token A address. Token B address. B address. And where can we get that? So we actually don't have the token address info, but we do have the contract address info. And this is a tricky thing that actually we need to dig further. So we see this contract address is, let's say this example is TRAC token, and each token contract has to be created initially. So when it's created, there will be a contract creation event, which is called pool created. So from here, we can actually track down what's the token info for this pool contract. So this two will be basically the pair in this pool. I believe this is that token TRAC, and then this is WETH. So basically, we need to join on this event to get the actual token A and token B address. So we can see there will be a join here already. So and the table. Okay, I'm gonna just copy paste it from my pre-test here. This is called factory event pool created. We can take a look here. This is the event we just saw from EtherScan. We see token 0 and token 1, and that's what we want from this table. And then we can deal with it later. But this is token 0, say token 0 as token A, token 1 as token B. And then what else? We also want the USD amount, but it's gonna be need a lot of like conversion. We will need to also join on the token 0 and token 1 as the token contract token address. So let's do it without this conversion first as a raw trade table. What else we want? We want the transaction hash. Feel free to stop me anytime. And pretty much that's it. We also want an event index as potentially we want a primary key. Event index. That's also we also want the amount, and the amount is right here, amount 0 and amount 1. And we see sometimes it's like negative. We will just make it a absolute value. So let's say amount 0, token A amount. Oh, raw. Copy. Copy. I think this has everything we want. Basically, trader info and then token info and then amount info. And now let's look at this join. Let's say T and F. Someone gonna speak?
Yes.
Yes.
Hi. Thank you for this. It's going great so far. I'm learning so much. But so for the fee parameter, does that need to be included, or is it
Fee.
included?
That's a good question. Fee parameter. 1 second. Let's go back here. Which specifically you refer to?
If you go back to the screen you were on,
Yes.
I was just
Here?
looking on the left-hand side.
Mm-hmm. I
And
see. Yeah, okay. So this fee, we can look at here. So this is pool creation. This is basically that table we're looking at. And
okay.
then this is index top, this fee is index top 3, which is here, and this says like 3,000, which is basically the, how to say, the fixed setting for this pool of the liquidity, how to say, provider's fee for whenever you are extracting liquidity from this pool. You're adding like 30 BPS to the trading volume, and then collect that fee towards liquidity providers. So this is when we calculate when we calculate what's the income for a liquidity provider, then we will need this for sure. But for reporting trading volume, we basically gonna just get the token amount and then join on the token price as the trading volume.
Okay, I see. Thank you.
Yeah, sure. Okay. We can then test maybe how this table gonna turn out. Okay, let me finish this drawing here. So we are sure that whenever there is a trade we see, right, this contract is created. So I can safely use like inner drawing here on this factory table. And then what will be the key we should join on? We know that the contract address or the pool contract address is the key to join on, and that was called contract address in the previous swap table. So I'll just say contract address equals to F. What is that called in the F table? Is it contract address? We need to check that. In this table, that this contract address that is logged in as contract address is actually the factory contract, which is not the thing we want to join on. Instead, this is where it's logged, which is the pool address. So basically saying we will need to join on here. Call it pool. Okay, so we can probably just truncate the whole query. Let's say limit 10 and see if this is gonna work or not. Oh, it's ambiguous because both of the table has the same, but probably gonna, yeah, it's gonna be the same too. Pick this table. All right, this works. So basically we're looking at like a example list of the Uniswap V3 trades we decoded. Let's see, we have the time, number, transaction hash, trader A. Trader B is empty because we know it's like full contract. We can also basically just put this contract address here. But whatever. Token A address, token B address look fine because we know this is WETH. Token A raw amount, token B raw amount. So now the next question is how we can report the USD volume or the trading volume for all those trades. Let's put this into a subquery or like a table. Let's call it like raw trade. Okay, put them inside a bracket, and then now we have this whole raw trade table, and then we will have to join on. So basically, where we can get the volume is this is the key part is the token A amount raw. We obviously need to divide it by the token decimal, and then we need to join on that price of the token at that moment, and then basically that will be the trading volume in US dollar. So let's say we're gonna select things from this table. Okay, so raw trade. And then what are the things we need to join on? So I'll call it R. And then, so as we said, we need to join on a ERC20 token information table to know the decimal. ERC, let's see, 20 tokens. Did we cover this table before? Probably. I remember. So
The dex.trades table?
The ERC20 tokens.
Oh no, we've gone through prices.
Okay.
I don't think
Oh,
we've covered ERC20.
okay. All good. So yeah, it's pretty easy table though. It's like contract address, the token contract address, and then the decimal and a symbol. I sometimes just do some dirty check like this. Select things from this table, and then limit 10. Wait, what's going on? 10, and I'll just select this part, and it's gonna just run whatever I selected. So let's just check. Okay, yeah, contract address symbol. Okay, this is a unicorn, and then decimal 18 look good. All right. Okay, I'll remove this. So basically saying we need to join on this table. Let's oh god, let's call it token A. Join on what? We need to join on token A dot contract address and join it with the raw table where we want to check, let's say, token A address. Same thing goes for the other side of the token. Call it token B and then token B contract. One thing though, it's possible that maybe this table is not complete. So in that case, we don't want to lose any raw trade. So I will just use the left join here, even though the domain or the field I want to get from the table is empty. The raw trades table wouldn't miss any records. So I'll just put it like left join here to be safe. And then, okay, let's say we want to get the token A raw amount, and then I will want to divide it by 1, what is it, 10, and then I want to get this decimal info from this table, and then decimal some decimals. What else? This will be basically the amount that is no more raw, right? So let's say we saw like 10 times 18 times, how to say 10 sorry 1 times 10's 18 times of WETH, and then now after division it's like 1 ETH, and then still we need to join on the price. So basically we need to have price here, and how we get the price, let's see. Now we need the price table, which was, I believe, prices.USD. Okay, apparently I cannot cover anything more than this exercise, but I can also do another session tomorrow for the focus group to. Okay, so now we have this price USD table as well. We need to join on it also twice. Let's say price A PA on PA dot contract address. Equals to R token A. And
Sorry, just a quick question.
yes,
Why we need the square bracket around the
Oh.
price and we don't need it for other?
all right, I just put in I'm just putting a note here as like the things we need to fill in. So I should probably
Okay.
yeah. And then another key, as we mentioned earlier, is the time we want to join on. And then in this table, we see it's minute level. So we will need to truncate the timestamp to be minute level as well to match this. So let's say we take minute from here. Minute. And then what we can get as a time information is this block time that we got for raw trade table. However, this is a timestamp with seconds. Let's truncate it to be minute level as well. Date trunc be this. Okay, so with this, it's complete. We can, how to say, retrieve the price info. We just do it for another side as well. Token B, B pretty much should work. Now we can actually remove this part to replace it with a price. So price here, gonna be, suppose it should be correct. And then also we're using the A side, the token A, so it should be token A price. So this is like either A side or B side would work, right? But what if one side of them has a missing info? In this case, we can just to be at a double, double safe, we can do a coalias. This function basically saying if the first one is null, then go to the second one. And then so basically we're gonna have the first part and then like comma, and then just fill in with token B. So token B amount, token B decimal, token B price. And this is basically USD amount, assumingly. And we can, let's see, we can verify with maybe a few example. Let's say we get a transaction hash as well. And we just limited it to like 10. And then we can, quickly get a result. Oh, it worked. Nice. And then so we basically calculate the amount of transaction on Uniswap V3. We can verify if the amount is similar on Ethereum on Etherscan. So let's see, it's 1800-ish. Okay, it doesn't really match, but it's very likely because there are, okay, let's diagnose why. Token A, okay, yeah, we need to also get the token A symbol info, which is here as well in the price table. We can get it from, let's say, token A symbol, PA.symbol as token A symbol, token B symbol, PB. And let's see which pair it is, so we have a better idea. Okay, so this is TRAC and WTH. Why it doesn't match here? It's possible that I messed up something. So it's 7796 TRAC and then 0.78 Ether. Let's get more of it. Token A amount. Let's see.
I guess that's reasonable, right? Because the amount is in USD. So I guess if you convert 0.75 Ether to USD, it should be around this one. What's the issue?
The issue is that we see the USD amount, right? It's like 1800, but I don't see 1800 here. So I wonder why.
That's it, right? Because if we are not converting USD, right? So if you can just convert quickly what the Ether amount is to USD for that time, I guess that should be equal to 1883.
Yeah, let's take a look here. So raw amount divided by decimals should be the amount that we saw on Etherscan. So we should see 7796, which is correct here. 0.786, 0.78. It's slightly different though. Here, it's weird to me, but that's how we usually.
That's correct, right? So if you can look at the transaction action, so you'll see the swap, the numbers are matching 0.75.
Yeah. So I don't know if it's because I think this USD value showing is actually not accurate because it's showing like the price of right now. So like you see the Ether price of the transaction time is like this. If we time this with 0.75, it should be what we calculated. Let's see. So I believe it met, yeah, so
Yeah.
this is pretty close to what we calculated. So yes, we successfully calculated it. Nice, great job.
If you click on the price on Etherscan, I think it goes back to what it was at the time.
You mean this one? I should click.
Yeah.
Nice. Thank you.
Yeah, I've had that come up before and thought I went crazy. Yeah.
Yeah. Cool. Actually, we don't have much time, and I don't want to actually extend everyone's stay. But any questions so far? I guess one last thing I can do is that we can just do some group buy for this. to just show how we can basically aggregate the volume over time. Let's say this is the result. And we want to get also, meanwhile, any question, please? We can do day. Block time has date. And let's just sum up the USD amount. So basically we can see every day how much the US dollar value is. Also note that to make sure it can run fast, it's just limiting 10 transactions. So definitely gonna the chart gonna be look weird. But let's see. Oh, sorry. Yeah. Oh. Meanwhile, any questions? And also, Andrew, I feel like probably we need to have another session tomorrow then. What do you think?
Yeah, to go deeper into this. Was this just the first exercise? Sorry, I lost track.
Yes, this is the first exercise.
Yeah, I feel like dex trades are always a lot to go through. We can do like exercise 2 as homework, and if you have time tomorrow, maybe you can help me with the focus groups.
That sounds great. Okay.
Yeah.
Cool. So yeah, a few other things is just like I want to like show you guys like what are the metrics we look at for DEX, and then like we try to do like a window function to make sure you know, we can do some more complex stuff. I can probably just jump in maybe the first 30 minutes tomorrow to cover those. And we're gonna have recording, so whoever can make it, it's fine. Don't worry. All right, I guess that's for now.
Yeah, that'll be awesome. All right, same time tomorrow then.
Yeah, sounds good. We have 2 more minutes. Any questions?
Also, I actually have a question about the source of the price data. So since you mentioned that the aggregator, like the prices are maybe different across DAX and aggregators, so where did price actually come from?
That's a good question. I don't know, was that Andrew covered it? Maybe you have more information, but also this table is also constructed from that repo. So if I'm checking it, I believe in the past I also. Sorry?
I can't see the table. I think the
Oh,
streaming ended.
yeah, let me see. Actually, just section. So I was just browsing through the repo and then prices table here. And we can actually see how. Okay, so it looks like it's from this source. Prices. Oh, okay. So USD value prices deprecated. It's not very explicit how it is here, but from what they also documented here, it's scraping the prices from 2 sources. It's called Coin Paprika and also CoinGecko. And then they're ingesting these 2 sources into the price table. In the past, I believe I also worked with someone from Balancer to also fill in some missing price based on the past DEX trading volume records. So it's like if we do miss some price token price, but we actually know the other side is WTH, and then we know the WTH price, and then we are able actually to calculate the USD volume for the trade. We can actually come back and then infer what's the token price for the other side for that trade. And in that way, we actually backfilled some token price info into the table. Does that make sense?
Okay.
Yeah.
Well, the second part doesn't really make sense to me right now.
Okay. I'll chat you about it. But
Yeah.
yeah. Yeah, how to say, in the fraud, how to say, in an easy way to put it, it's like scraping some off-chain sources like CoinGecko and CoinPaprika, and also I think there are also some process to fill in the missing part from DEX trading records from the past.
Oh, okay. So you mean like there's some price related data that are on chain
Yeah,
from the
yeah,
DAX?
yeah, that's right.
Okay.
All right. Okay, we're at time. Appreciate everyone coming. Thank you, and I'll see you tomorrow again. Bye.
Bye. Thank you.
Thank you.
Thank you so much.
Thanks.